Welcome, everybody, and welcome to the second of our workshops on understanding AI models. Today, we're going to be talking about understanding text-to-image models. I'm Jesse Spencer-Smith, and I'm Chief Data Scientist at the Data Science Institute, and I have with me some of the data scientists and postdocs from the Data Science Institute, including Professor Bell, Shara Bell. We have Dr. Petulante, Abby Petulante is a postdoc with us. And we have Umang Chowdhury, data scientist with the Data Science Institute. So we're going to be here to be able to answer any questions that you have. We're going to have a presentation for about the first hour. It's going to be interactive. And then for the last half hour, for those of us who can still be here, we're going to do some hands-on with some pretty interesting tools. Much like the rest of the AI space, things are moving extremely rapidly with image generation. It started out a little bit more slowly, as you're going to see, but really over the last couple of weeks has taken off. But it's not all good. So we have a lot of bad with the good, and we're going to talk about why that's the case and where that comes from. But first, I'd like to start with some ideas from you. Who here, and you can just do with a virtual show of hands or actual show of hands, who here has used one of these text-to-image or image-to-image models? This will be either Dall-E or Stable Diffusion or something like Midjourney or Dream, something along those lines. Who has some experience? Excellent. Dr. Ya, so, and Brooke, excellent. And Abby, I know that you have as well. So Dr. Ya, tell us a little bit about what you've done with these. And it's nice to see you.
Thank you so much for hosting this session. So with Midjourney, it's mostly just been for creativity. I have a sixth grader and a first grader, and we usually just use it to kind of like explore concepts and think through art. And I think it's an interesting way to teach kids about coding or prompting, just the concept of prompting and having them articulate what they want and to be able to manipulate the subsequent drawings based on features they want and the limitations, like too many fingers. Why is that? What does it not know? So things like that. It's been really fascinating.
Fantastic. And at the very, in about the next half hour, we're going to hit something that I think you're going to find very interesting, which is a development in the last week in these models. What a great use of that. Anybody else? Brooke, you've been using this quite a bit. How have you been using the models?
Did you say Brooke? Sorry.
I did.
Yeah, I've been using it. I'm the communications marketing PR person for the department now. And I've been using it for images for our stories, for different graphics, like for our upcoming Women in Data Science conference, which you'll see in a second. And just for various, graphic design usage.
Okay. Fantastic. And Abby, you've used these as well. Let me ask you, Abby, what are some problems that you've run across? Like just for rendering images?
Yeah, I mean, I think there's a lot of problems. I mean, I think like Dr. Ya kind of alluded to, it's really hard to get it to give good looking people a lot of the times. If you want to make people, you have to put stuff in the prompt, in the negative prompt, like disfigured, too many fingers, bad anatomy, scary eyes, and sometimes it still just wants to generate those things anyway.
And you would say negative prompt. What does that mean?
A negative prompt, so yeah, Stable Diffusion has positive prompts and negative prompts. So positive prompts are things that you want the image to look like, and negative prompts are where you can emphasize things that you don't want the image to look like. And so a lot of times people put in negative prompts, kind of things that they find Stable Diffusion's doing that don't really fit into like you can't really put like normalize into a positive prompt, but you want to kind of emphasize to not do something in the negative prompt.
Excellent.
But I think it has a whole host of other problems that we will maybe talk to about sort of presumptions about what people and things should look like that definitely make it very hard to generate certain realistic images. Yeah.
Fantastic. Actually, we're going to start with that. So let's talk about where the models are trained from. Then we're going to dive into a problem that we had here at the DSI this Friday for generating images from for women in data science and for another, just generating images, and how this can, it's pretty insidious, how this can sort of creep in and it can reinforce stereotypes when we least intend it. But let's talk about where these models come from. We'll get into the more technical detail in just a little bit, but does anybody know where the images come from that these models are trained on? Because it knows about all sorts of different things, styles of art, it knows about different images. What is it trained on, do you suppose? Dr. Yeah, please.
Isn't that part of the controversy of supposedly on open set data and images that are openly available? But I think there are some places like Getty, et cetera, that are saying that they scraped some of their artists' information, and the artists are not pleased. Absolutely.
So it actually is scraped. So a lot of the training information is scraped from the web. So first pass, think about images on the web. Already, we start getting into some issues. So what appears on the web? Well, you have news images and you have other images as well, but some of these are held, with copyright. Some of these are intellectual property. So that's part of it. That definitely goes into the training of many of these models. Then what also goes into the training is something which is maybe not so obvious as a problem. All of the because these aren't just pictures, these also people generated pictures as well, drawings and sketches and paintings. So think about all of the presumptions and biases that go into the things that we create. So much like with large language models, which are also trained on text found on the internet, here you have also models trained on what's in the internet. So any bias which is apparent, and bias in the more lay term, right? Not biases in terms of deep learning, but bias in terms of the lay term usage that is existing in the images on the internet are going to be learned and encoded by these models. So why is that a problem? Well, let's think about generally what these models do, and we're going to get a chance to try this out, and let's see what the models actually do for us. So in this case, you can see our Women in Data Science 2023 upcoming conference, and this was the prompt, Brooke, that I think that used, which was diverse group of young women sitting around computers, Asian woman, Black woman, cool, pop art.
Yes.
So first of all, we had to say diverse group. What happened when you didn't say diverse group?
It wasn't diverse.
Yeah, and it was not diverse in a weird kind of way, right? And so,
Yeah.
But it was, and this is where the biases start coming in. Many of those images that were generated there were of Asian women.
Mm-hmm.
And also very heterogeneous, very homogeneous as well. So get a better representation, then you get closer, but technically, can anyone identify problems with this image? Not even thinking about bias, but just technically. And Abby, you're probably gonna peg this one right away. What do you see?
I see a bit of a weird looking hand on a thing, I think.
Yeah.
I always look at the hands in Stable Diffusion images because they're like never quite right.
So it can't, right, so it doesn't do the hands. And you mentioned a way of fixing that problem at least. So what's one way of fixing that problem?
So I think, yeah, the common thing is to put a negative prompt where you try to specify the correct number of fingers and like normal length fingers. You can put it also in the positive prompt and say like a group of people with normal hands or something, but I think that doesn't tend to work quite as well.
Okay, excellent. Now, what about some more subtle issues here? And we'll see another image that we also generated. You'll see it right away. More subtle issues here.
I don't know if this is just an extension of the hand, the fingers, but the hand is not quite connected to the hand on the keyboard. So
Yeah.
that's interesting. And eyes are sometimes a problem. These ones look reasonable.
They're not bad. But you're right with the hand, absolutely. Plus, where's the screen? So generally, it's kind of like these different elements kind of make sense, but it's like, what are you looking at exactly? If the
Right.
screen's over here. Then there's the images themselves. Not bad for such a simple prompt, but where are the plunging necklines coming from? I mean, seriously, it's like we didn't say anything about that, right? And it went there. So here's another image. So this is almost the same image for another thing for our newsletter. And so this was very close, but this was supposed to be digital art, cool techie. Why? So this is where it went. And is it the case that sort of all images are going here? Well, let's go ahead and say, let's do that same prompt, but let's say men around. No, we don't. All right, so we don't have any plunging necklines on the men here, but so, and you can see there's a difference sort of in the look as well. And so this is a recognized problem, right? So this is a known problem. Contrastive language vision AI models pre-trained on scraped multimodal data exhibit sexual objectification bias. Definitely. So notice that was nowhere in the prompt. It didn't come anywhere. As a matter of fact, if you have people around a computer, you would expect it to go one direction, but it went in another. So how can you fix this? Well, one way is possibly you could ban terms. But this gets more against like trying to block the generation of porn, because you could certainly generate that as well. So the problem here is, and this was an article from the 24th, Midjourney tried to block porn generation by banning any words about the human reproductive system, primarily on the female side. And so if you try to generate images that have to do with fallopian tubes, good luck, because Midjourney's banned those now. So not a great approach. Brooke, tell us about what happened when you tried to address these problems with the images by using the term not sexist.
Yeah, I try to use the term not sexist, unsexist, a couple different variations of that. And anytime it has sex, like sex at all, even if it says not sexist, it's going to ban it completely. Like any variation of that, yeah, it just says unable to generate words banned.
So positive ways to address this, perhaps dressed for office. Okay, a little bit better here. So, but still, look at this image right here. Still, even when you say dressed for office, it's still pushing in that direction. Do we see that when we also do men? Not quite. Also, you'll notice something else interesting here. Do you notice anything different, different about this? So this is a group of men, a group of women, tech. Well, let's see, what was that? It was the same prompt. Group of young, diverse men sitting at computers, coding digital art, cool techie dressed for office. What are some differences you notice between these two?
The color palette.
The color palette. How about how they're, and this is open for everybody, how they're sort of dressed? Which looks a little bit more professional, or which is the most professional looking image?
Certainly the men, the ones with the ties.
Yeah, so there are ties here, but you don't see any instances of that here. So,
and it's interesting, the girls seem to have headphones. That jumped out at me a little bit.
Oh, that's interesting. Yeah. and none over here. Interesting. Anything else that anyone else would like to comment on?
Yeah, I think going along with the colors, just kind of, yeah, like the art style is almost, it's a more serious art style for the men, and it leans more into that like pop art, cartoonish for the women.
So, a couple of things that we learn from this. One, the bias is inherent in the learning of the images and of the wording as well. How do these two actually interact, and how do you even get to images from text? That's what we'll be talking about today. Two, that up until state of the art, let's call it 2 weeks ago, this is about as good as you could get with control. So it had to only be text. If you wanted to do more control, you had to do it either with positive prompts or negative prompts. And you can see how squishy that is. You push in one direction and it sort of goes in another direction. It's almost like whack-a-mole, trying to get everything in the direction that you want. So what we're going to be talking about today is, and our goal for the end of today, is that by the end of this first hour, you have a good sense of how these models work, where they come from, how they can be used. Then we're going to be talking about the different varieties and how they've evolved. So where they came from, where they've evolved to, and where this most recent iteration has come from in this last week, this brand new iteration that offers much more control of these models. And then we'll talk about what is likely to come next. Before we jump in, questions or observations before we start tackling? Excellent. Then let's start closer to the beginning. So in 2021, there were a couple of nearly concurrent publications, and not releases of models, but publications about models, and then open availability of models around the same time. These were all around this idea of being able to generate images directly from text. So if we take a look at what these were able to generate, you know, it's not bad. Here's an example of models that were generated. You'll notice that well, first of all, that they weren't great, right? So you see some garbage here. They're very sort of simplistic. They're not necessarily photorealistic, but still pretty stunning, because we had never been able to say something like, hey, just give to a deep learning model an illustration of a baby hedgehog in a Christmas sweater walking a dog. That was something we were never able to do before. So these produced simplistic images, but they could do it. Text was more difficult with these. You could see that, you know, especially with this one, they're cherry picking here, right? And this is the best they could get. The other thing with these models is that they were huge models. They did this in a particular way. How many of you were here last week for understanding ChatGPT? So Ben, I see, yeah, you were here. A few other folks were here. So, oh, and Becky, oh, fantastic. So in those, you know, we talked about these large language models. What they did here was they took those same large language models, but trained them not just on text, but also trained them on images together, a multimodal model. And so they could actually put in as part of the prompt, and it was almost like a translate this text into an image, and then this is what it would generate. Downside was huge models could not be run on any sort of standard hardware. It couldn't be run on something less than a huge server farm, which is why only the largest companies had it, and why they didn't well, other reasons why they didn't open source it. But you know, this requires many computers of significant power all combined together to generate even a simple image. And they recognized early on that there was problems here as well with the possibility of generating very problematic images. So nearly at the same time, shortly after that, so you'll notice that this first one was 2021. Then in April of 2022 was this next generation of models, which worked in a very different kind of way. Interesting thing about this, you can think of this as being two different models yoked together. So the clip models were trained on providing text summaries of images. So given an image, this is a dog standing on a sidewalk in front of a house, the clip model would actually generate the description of what was in the image. And the trick here was to take that clip model that was trained on image and also trained with text, but to reverse it. So now, once you reversed it, now you could have a textual representation. And then from that, you could generate the image. And this used a process where you were simply, you were running it sort of in reverse. Again, the model which came out of this called Dall-E 2, hugely computationally expensive because it was operating at the pixel level. So the problem is this: here's a random set of pixels. How do we move the pixels? And so when we compare it to clip, the description becomes better and better and closer to the text that we put in. You're solving this interesting inverse problem of trying to move this random image closer to the image, closer to the description that you had. So Dall-E, far more successful. So now we're getting into things that are much more realistic than the very first one. And now you can do things like oil painting by Matisse of a humanoid robot playing chess. Not bad. So part of the change here is now you're training on many millions of images, whereas the first model was only trained on some. Now this is trained on millions of images. So now it has learned things like style. So it understands Matisse. It understands a photo of a white fur monster standing in a purple room. So now it understands the difference between drawing and photo and the type of representation. So down here you have a Van Gogh style painting of an American football player. It understands what American football is. You know, they actually even has pads on right here. So now getting far, far better looking images, still very difficult to generate and requiring large scale computers to be able to do this. So a non-trivial problem. So again, now we're also in April 2022, nearly at the same time that Dall-E 2 came out, another group came out, and this was the group that became Stability AI, came up with a way of solving this problem in a different way. Recall that all of these images were created going from pixel to a final image. So the main idea here is that you're already going to be operating in a latent space. So you're going to take this image and then you're going to be, Clip is going to look at it and it's going to come up with a representation of this, just like with the large language models. And that's the latent space. So what's happening in this image, there's going to be a representation of this within the deep learning model. That's going to be your first step. So you get up into the deep learning model. Their idea was, why do all this work in the pixel space? Start right up here in the semantic space and do that work here. So let's talk about how Stable Diffusion generates its images and why it's able to do as good a job, if not better, than these huge models, but to do so much more efficiently. So let's take a look at the architecture that we have here first. So what you're looking at here is the architecture for a Stable Diffusion model. You have input here, which can be image. You have text input as well. And the very first thing that happens is that this gets represented in the deep learning model in what's called a stable diffusion encoding block. So much like in the large language models, you take the text and the very first thing you do is you represent it mathematically as what's called a semantic, in a semantic space. You're representing these not just as a collection of pixels, but as a semantic representation of what's in the image, all the different parts that are in the image. So you start there. So you're no longer working with just the individual images, right, the individual pixels. Now what you're doing is you're squeezing that representation down. So at first it represents everything in the image. Maybe this blade of grass that's right behind the dog is not important, but it's represented there somehow. So what happens is, and this is called a U-net, the representation gets squeezed down. You'll notice that this is getting smaller and smaller, 30 by 32, 16 by 16. That's the size of the representation. So it's getting smaller. And you're adding noise. And now what's happening is that you're getting rid of the noise and you're getting larger again, getting a richer and richer. So what happens is, if you start with just the text, then this is just noise. And the text is driving everything. You could put text and an image, but you're adding noise, squeezing it down, and then the text is causing it to balloon back out again, but now including more of the semantics in the text that you had. But all of this is happening in the deep learning a latent space, so it happens much faster than trying to move all these millions of pixels around. So what's happening at the very, very end, then it generates an image based on the latent information that's been added into this model. So you don't really, until you get to the output, you ever really need to be getting all the way back to the level of the pixel where it gets big again. So in short, you have the text, you might have image, you may just have noise. It squeezes that down until it's the smallest possible representation. It removes that, gets it larger again, and then generates a new image based on the text that's driven it. So very high level. If you're interested in getting more in depth, we're actually going to have a workshop over the summer where we can dive into the mathematics of this as well. But questions about this so far?
Can you explain more about time encoder here?
Yes, so these encoder blocks, first of all, are pre-trained. So these are pre-trained on millions of images. So its representation of what an image is well informed by all of the images that it's been trained on. So millions of images along with text, because remember, clip can generate that text from the images. So it's learned the association between image and text. So the text that you have right here is represented in that same space along with the images. So think of a projecting into another space where you might have a totally different set of basis functions. In this case, your basis functions are going to be all of the semantic space around the images. So what does that look like? Well, it depends on what it's been trained on. But know that the training of this, the pre-training of this is expensive. So this is expensive to do the training. But the inferencing, where we just put in text and we put in the image, is actually far less expensive. That actually just looks like matrix multiplies all the way down. So you take the image and you take the text and you say, please represent this in this large representational space that you've learned. Fantastic. Now that we're there, squeeze it down to a smaller representation. So you can think of that, saving only the most important things. Now take it down again. So now you only get to save the most important things. And so this image that I may have started with, they've had a whole bunch of things, but what's the most important part of the image? In order to save most of the information in the image, the semantic information, what's most required? And now let's begin to grow it out again as we get down to the lower layers. And that's where the text encoding drives that recreation of the text. Does that answer your question, Sanju? Oh, and you're still muted.
I was wondering about how time encoder works in this system. I can kind of
Oh, the time. Oh, I missed that. I'm sorry,
encoder
time.
decoder things together as you described, but it's not that clear how time encoder works in encoder decoder.
So Stable Diffusion actually can also work with video. And so that's going to be a crucial part for this. I am unsure, and Abby, tell me if you know differently, if the time encoder is essential for the image only.
I am also not positive about that.
Yeah, I don't think it's necessary for the image only, but Sanju, I will check. Because I know you, I think I know your interest in this, absolutely. I will check on that. I don't think it's necessary for that, because normally those steps that I was talking about are captured naturally in the architecture. So I don't think, and to get really into what's happening here, this is a reversible Markov process for the injection and the removal of noise. That's what's happening with the UNet, not unlike what happens with UNet more broadly. Other questions? Okay, so this made a huge difference. So Abby, can you share a little bit about what you are able to do with Stable Diffusion models? And maybe you can sort of share your interface. Take about 5 minutes if you could, sort of share what you did and what we did for our AI Valentines a few weeks ago.
I'm muted, sorry. Yeah, I can share.
Here, give me 1 moment. You're going to be co-host and you should be able to share. There you go. And while you're getting started up, I'll describe what we did for our AI Valentines. First of all, did anybody here attend the AI Valentines? Anybody stop by? It's mostly undergraduates. So for the AI Valentines, we first of all use large language models to generate love poems in the style of different poets. You could describe your Valentine, and then it would write a poem in the style of a poet about your Valentine. One of my favorites was I had one generated for my wife in the style of Sylvia Plath, which turned out to be a dark, but actually rather good Valentine's Day poem. It ended nicely. So, you know, interesting juxtapositions there. The other thing we did was you could generate Valentine images based on Stable Diffusion models. So you could describe what you wanted to have. And the fun thing was that we also had, you could do, we had temporary tattoos that you could generate with these as well. So we had a lot of fun generating temporary tattoos. And Dr. Yeah, absolutely, we will add you to the mailing list. And we're going to break out those tattoos again, because those were a lot of fun. But Abby, we were just talking about the Dall-E taking tons and tons of compute. How did we actually generate the images for Valentines?
Yeah, okay, so I'm pulling up the, this is what we were using for AI Valentines to generate images, which is a nice thing that somebody else made. I did not make this, for running Stable Diffusion and basically getting to like play with all of these different kind of things that you can mess around with to generate different images in Stable Diffusion. And there's both text to image modes here and image to image modes here.
And let me ask you, Abby, where is this running though? Is this running on a huge farm of GPUs?
No, so this is running on just one little GPU via Google Colab.
So free Google Colab, and it's running on free Google. So we've moved from Dall-E, where it requires a farm, even inference, it requires significant compute, to being able to generate these images just based on a single 2 generations old GPU. So here you did a picture of a galaxy. This is especially funny. So Dr. Picciolanti just completed her PhD about 6 months ago or so in astronomy. So this is especially funny.
Yeah, and you saw, I mean, just how quick that was, right? I enter a picture of a galaxy, and I mean that, in my professional opinion, looks like a galaxy. And it generated it in like 5 seconds. So it's pretty incredible.
So huge difference between stable diffusion models and diffusion type models versus the original version was much smaller, extremely fast to inference on. Can you talk a little bit of view of the problems that you had though?
Yeah, so I had a lot of problems. I think in text to image, things are a little bit more open, even in, you know, in your idea of what you want to generate. You don't, sometimes you have an exact image in your mind, but a lot of times you kind of are a bit more open to what it gets. I think image to image is very challenging. In particular, if you have an image and you want to make the resulting image look similar to the input image, it's very hard to get it to not just kind of completely change that image. And so I've had a lot of challenges getting image to image. We talked about, you know, creating people who look good. We also, have issues with it changing the races and genders of people.
In what way?
Well, in kind of a two-way, where it definitely prefers making people white, particularly if you have things like a group of beautiful people or successful people, or like, you know, the more kind of positive words, the more that it kind of thinks that's what it's supposed to make. But also just it really doesn't like to create diverse groups of people. It seems like if it is going to make somebody in the image of the race, its presumption is that people of a race only hang out together. And so that if I'm going to generate one person of a particular race, everybody in the image should be of that race, because like diverse groups do not exist. And so even in an image to image, if it changes the race of one person, odds are it'll change it of everybody to match, which is not usually what you want.
That was a challenge, wasn't it? So actually, you know, because people were giving us their images, and so that was actually a fair amount of the work that you were trying to do with people when they were creating images. Yeah. So the models are becoming more and more powerful, but we're still not addressing the issue, which is what they're trained on. So you can think of this as, in some ways, this technology is us holding up a mirror to ourselves. This is when you train a powerful general purpose learner on all images and all text, this is what it's seeing right now. So are there any other images that you'd like to, or any of the other capabilities you'd like to show us? I see that you have the positive prompt here and then the negative prompt. No scary eyes, not disfigured, not ugly.
Yeah, so this was an image that I was trying to just change like the background. So there was a group of people, they did not initially all look like this. And I was mainly trying to just change the background of this image. So they were not originally in front of a brick wall. I was just trying to say, let's put them in front of like a more interesting background. Maybe that would be a use case you'd want. And yeah, so I mean, one thing you will notice is despite me putting in the negative prompts, and these double parentheses are just supposed to give extra emphasis to that thing. And despite me putting in the prompt not to kind of make them look weird, that you will notice if you look at the faces, lots of them look very strange. It is definitely a challenge. And then you'll also notice in the positive prompt, again, to try to sort of create a realistic looking image, I have all these words like you can specify the camera you've used. You can say HD 4K image quality. I repeat again, a high quality 4K HD photograph. So all of these things are kind of trying to, you know, direct that kind of style to be in a particular, you know, high quality photograph. But it's still a challenge. It really is very hard to get people to look good in Stable Diffusion.
Thank you. Thank you very much, Abby. Anything else we should know about?
I don't think so. Not right now.
This is great. Thank you so much. So let's go ahead and see if we can get a sense of why controlling these is so difficult. Let's take a look again at this architecture. You notice right here with this architecture that text comes in only at the beginning. So that text is only in the beginning and it gets encoded, and then all of this work is done being informed by the text, but that's all. It's not driving it along the process at all. So different tricks that we'll put in try to emphasize it, and so that representation becomes heavier and heavier with both the positive and the negative. But is it going to make it to the very end? You know, maybe or maybe not. And then you also mentioned something else that was interesting, which was you were trying to replace the background, right? And you couldn't do it because you were having to do that with text alone. So, did I mention that things are happening at a breakneck pace? Well, let's go ahead and take a look at a publication that came out February 10th. Do you know about this one, Abby? I've been out this week, so I've not had a chance to tell you. So I don't even think I've told you about this yet.
Yeah, I don't think I've seen it.
So this is adding additional conditional control to text and image diffusion models. The idea here is that if you try to train a model to be in a particular, to follow a particular style, or to perform in a particular way, you risk disrupting all of the learning. So Abby, there were some models that were pre-trained and fine-tuned on specific types of styles. Can you describe some of the specialized styles that these diffusion models, stable diffusion models, were trained on?
Yeah, so for instance, like people fine-tune models with the specific goal of creating like images that looked like Van Gogh had painted them. So you could take any image and put in like a little token for Van Gogh, and then you'll always get something that looks like Van Gogh painted it. Or that same idea, but with different art styles, you know, pop art or comic or pixel art or whatever it is.
Fantastic. So one of the things that you gain when you get a smaller model is that it's faster. You can inference it on almost anything, and it's open source. Stable Diffusion, completely open source. You know, you can build your own, and you can train it as you wish as well. But the problem with that additional training, sometimes it forgets what it was originally trained on. So that means you might actually get you might get worse performance generally out of it, even though it gets better and better with Van Gogh. Remember, with Dall-E, you could simply say Van Gogh, and it was going to give you that. But that's because Dall-E is huge, you know, huge model, and has been trained massively on all this. And so it can do better at getting to particular styles. So that's one problem. How do you train the models with additional styles without losing everything you had? Two, how do you control the generation of the image in a particular way? So you want to replace the background. You want it to match another image in some way. Let's say that you want to do image segmentation, and you want to say you want to replace all the people, or you want to change just the background. So leave people as they are, but change the background. Impossible in current approaches. That was until this was released. What is that? 2 weeks, 1 week ago now? A little bit over a week ago now. So with this, the idea is you never actually touch that underlying model. Instead, you have a dual version of the model that you can do additional training on. So what does that look like? Well, it's a very clever idea. And I think it's one that we're going to be seeing also in the large language space, quite possibly. And that is, you have a dual model. You have your stable diffusion model, and then you have your control net model. So this model starts out as just a plain copy of what you had before, but now what you do is you can allow yourself to do very heavy training of just the encoder blocks. So this means if you, given whatever kind of training paradigm you want, you can heavily train these. At inference time, you still have benefit of everything that was learned before because these are all locked. But now these are trained, and so if you want to go a particular style, and we're going to see you can do many things other than just style, you can do heavy training here. And remember, heavy is not all that heavy because these are small models, but heavy as in many epochs and on lots of data, and get very different behavior out of the model while maintaining the quality of the image that you get and never unlearning what you had before. So we're not going to get too much into the details here, but let's go ahead and take a look at what sort of capabilities this gives you with these what are called control net stable diffusion models. So first off, I'd like to note is this is completely open source. So love to see that, all open source. Description of what they're doing. You can go in, you can analyze the code. And the other thing is that they've done some significant pre-training on these models. So let's say that you start with a picture like this. You can use a type of filter, a number of different filters like canny edge. What canny edge does is just take edges, and then you can generate pictures from that. So this is one way of getting exactly the structure that you want. I want this picture, and here's what I want out of it. Now generate new images, and now you can do whatever you want to describing other parts. So these are not from the original image at all. These were trained, and these were generated only on the canny edge. So this is very fine grain control that guides the generation of images. You don't have to put in, no weird eyes or no weird feet, although they're not feet, they're whatever they're called on birds. All right, so that's one example. All right, how about a cute dog? So now we're going to do canny edge with a cute dog. All right, you're going to get the same cute dog, but now the fur may change, the coloring may change, all of that can change because all you're capturing here is canny edge. Sanjay, did you have a question?
No, I don't have a question. I just trying to understand what's going on here, which makes sense. Yeah.
Yeah. So here we have two things, right? So we have, this is the text, this is the image that you're putting in. So this is all that the diffusion model is seeing, plus it's seeing the text prompt cute dog. So if we were to go over here, what's going in here is the canny edge. So nothing from the original image. What's the prompt? Cute dog. Let's take a look at another one. So the other thing that you could do is there's another way of doing filtering, ML LSD lines. So this is just a way of picking out parts of an image that have to do with lines. So this is only getting sort of the outlines. So here's the original image. This is all that's going in, and then the prompt is room. So here, let me go and zoom into this just a little bit. So the text is room, and then this is what it's generating from it. So you'll notice it's respecting the different things that it sees. This appears to be a couch or something like it, and it's capturing that faithfully in each one. This could be a window, and it's capturing that there's a window there. It does something a little bit different here. Changes the flooring, changes the materials, changes the lighting, but the architecture is the same. Okay, let's do another one again with line maps this time. So now you have a building, and it says building. So the line gives you buildings of entirely different styles, but the building itself does not change between the two. If you were to put building in here and try to put a building like this, you'd get something in the old style diffusion models without control net. You'd get something that might look very, very different. It's not respecting anything about the architecture. Here, It's respecting the lines in the architecture because that's what you have put in. Another type of filter, and if I'm not mistaken, this is oil painting of handsome old man masterpiece. That might be the most interesting man alive. I'm not too sure from the commercials from before. But again, very little information here. And this is what it generates based on that. Same pose, same orientation of head. All of that stays the same, even though everything else might change. So, and again, here's the original image. This is what gets fed in, which is really just the line drawing. And then here's the different images that you can get out. All right, let's do scribbles. This one is pretty shocking to me. Here's an image where it was a scribble map, which is just like almost like a child's drawing of it. So you take a photograph of something, get a child's map. This is all that the control stable diffusion model sees. And then you say turtle. So now you get a turtle where the background may change entirely. This one's underwater. This one's on top of water. But it's filling in with coloring and with lighting and with background that makes sense for turtles. The pose of the head is the same. The leg is in the same position, but it's filling in only where it needs to. Okay, so Dr. Ya, where is your mind going with this, especially thinking of your kids? What would you like to be able to do with this?
I think the example of the turtle is just absolutely remarkable. And it's funny because I'm always just so in awe and impressed with these tools, but I suspect the people that just know the inner workings of it, or maybe there's some ennui, but it's unbelievable. This is just remarkable that we're able to do these things. And I just can't get over how impressive this all is.
I'm pretty odd too. For your kids, what would you like your kids to be able to do with this? So this is a generated scribble map.
I think, and I'm probably too much of a let's make everything a total lesson, but really to understand more of like, well, what's the difference between the scenery? Like, why did it pick that? Why didn't it put the turtle in the desert?
Mm-hmm.
And for them to just kind of really intuit what is going on in the background, and what else they could get out of it. Be like, well, if you wanted, if you drew a camel, how do you think it would render it? So things along those lines.
So that's where we get to interactive scribbles. So given an interactive scribble like this, and then the prompt, which is dog in a room. So you start with this, and then it generates these. Let's do this live. So here I have running on Hugging Face a control net taken directly from there, but it's running on my own. So it's on a beefy GPU, but only one GPU. And what I'm going to do here is I'm going to open a drawing canvas. Oh, is it? Are you still just coming up with it? Or is it? It may be spinning up. Okay. Now I don't want to load. I want to open a drawing canvas. I'm hoping that you will do this. Okay, I'm gonna try to restart this.
Earlier this morning, ChatGPT was down, so I don't know if they might be having some general issues, but Twitter was collectively just losing its mind.
This one, so it's having to rebuild. What the interesting thing about this is, and hopefully this will come up in just a moment, but the idea here is that you interactively draw some kind of a picture, you give it a prompt, and then it will generate different versions of this for you in real time. So let's go and see if we are up and running yet. Still building. Okay. But let's go and finish taking a look at what happens with fake scribbles. In this case, it's creating scribbles from an image, and you say bag, and then these are the different images that you get. Notice how photorealistic these are. So, and sort of right out of the back, it's because it's being controlled by that strong input of the drawings. It highly constrains what diffusion models can do. Same thing with shoes. So this is one way of going from one to the other. But now you can do things like human pose. So here's a person posing, totally natural pose. I do that all the time, you know. So a pose, right? You use pose extraction, and then you ask for chef in the kitchen with exactly the same pose. We can do the same thing here using a different type of pose model, saying, okay, so this is a pose of a person, you know, totally different, but you've captured the pose, right? And this says astronaut on the moon. So the astronaut on the moon has the same pose as what was in the picture. So the only thing that's being carried over now is the pose. Let's do image segmentation. So here you start with this image here, but remember, you're not using the image. You do image segmentation of this is house, this is part of house, this is grass, this is something else, driveway, this may be bushes. So render an image where this part is house, this is like outer part of house, driveway, grass. Otherwise, other than that, you get to do whatever you want to. So Abby, you can imagine in that picture, you do the image segmentation in people and not people. All right. Again, with the segmentation maps. And here you're saying river. You can also use depth. So here's a 3D image. If you capture only the depth, then you can actually create other images that recreate that same depth. Normal map, yet another way of pulling out information. Again, 3D information from normal map. This is just giving you, you know, that distance. So now you have other Abraham Lincolns generated just from the depth map. And here you have, you know, a depth map just from that particular person. So you actually are capturing pose because of that. Anime line drawing. So this in the last week. So a great deal of control that's possible. Oh, looks like I won't be able to do that interactively. In the next half hour, we're going to be trying some of this interactive. So we're going to be trying we'll be trying some of the interactive using Dream Studio. I emailed this to you. Hopefully you had a chance to sign in. So you can try the old style non-ControlNet version to see what that looks like. And you'll be able to get online. I'll send you the link for ControlNet. It may take a while for it to render, and I'm hoping mine will be up as well. So let's go ahead and conclude. These models, which have the ability to generate text from image and image to image, are really quite new. We've only had them around for about the last 2 years, and really they've only come into their own in the last year. A year ago, we're able to start working with models more interactively on our own hardware with the advent of diffusion models. Now, with the advent just last week of ControlNet diffusion models, we have the possibility of finally controlling the models and doing both image segmentation, semantic segmentation, and also transfer of only very specific parts of images that we want to have carried over to the new models. So these are great movements in development. But you'll notice that nothing that I've talked about addressed the images and the problems that we talked about at the beginning of the hour. So where is that improvement going to come from? Well, those of you who were part of the workshop last week might remember reinforcement learning from human feedback. That was something that really moved these large language models into something that was more useful. It mitigated the harm and bias, but didn't remove it, but mitigated it. My prognostication is that we're going to start seeing that same type of reinforcement learning from human feedback in these types of models as well, steering at a deep level the learning that these models have. Second, prompt engineering is going to become more and more important in these types of models as well. Brooke, when you and I were trying to fix the images and, not sexist, not working because they removed that, professional clothing helped. So that type of prompt engineering is going to be important as well. But also ControlNet may offer some ways of controlling that as well. ControlNet works not just at that image level, but could also work at the text level as well. So can we modify based on that? We don't know yet. That's open area for research. But what is certain is that whatever happens is going to be happening quickly. You shouldn't just take the model outputs and leave them as is. Be aware that we're holding up this mirror to ourselves and we may not like what we see. So be careful when you're using these, but absolutely explore and use them as broadly as possible to enrich the lives of your children, to use them in education, but just use them responsibly. All right. Let's finish up this first part. Thank you very much for all of your time. Let's move into some interactive work with this then. Anyone that needs to take off, we've had a number of folks already had to leave for at the 1 o'clock hour. Those of you who are still here, let me go and send a link to this ControlNet, and you can get this to work. It's going to take a little while for it to bring up. But this is the ControlNet that you can try. So that is ControlNet. But here is a link. You'll need to sign into this, but this is the link to the base diffusion model. So I would try the base diffusion model first, that second link that I just sent you. Go ahead and sign up, and I will actually share with you some of the things that I can create here while you're pulling that up, and then I'd love to see some of the things that you're creating. So first of all, questions before I start generating here, and then I'm going to ask you to tell me what to create using diffusion. What questions do you have?
With tools like ChatGPT, where you can essentially communicate your thoughts via prose, how far away are we from tools where you can use natural language to communicate with Photoshop? Say like, make that tree go away, or make her shirt red, move these two people closer together.
We are there, actually. The problem is that it's an imprecise knife. So I think what's going to be happening next is, especially with ControlNet being open source, very rapidly, these companies are going to do something along the lines of, indicate which part of the image you want to edit, right? And then using a ControlNet to only do operations within that. Or even better yet, something like, the outline. So click on what you want to edit and then have it choose either the outline or the semantic, right? So you can say, I want to only edit the house. Point to the house, this house. Then it will select the house by using semantic segmentation, then use ControlNet to only operate on the house. Right? And then, okay, for the house, do you want to change the structure? Do you want to change the, because then it's going to be, are you going to be doing like an outline? Are you going to be doing, these are all different things that are much better controlled with ControlNet. Like I said, because whoever creates those tools first is going to have a huge advantage. So Adobe is going to go there soon. They're not going to feel like they need to do it immediately. Plus, they don't want to kill their own business, right? But other companies absolutely are going to see an opening, are going to say like, hey, are you tired of wading through Photoshop? Here, yeah.
That's amazing.
Brooke.
Well, like in Canva and some other software, you can already just eliminate the background with just a click of the button.
Yeah.
Which is super convenient.
Yeah.
Just so convenient if you ever try to use like the magic generator to try to like get an image out. So it's pretty amazing.
What shall I try here? You'll notice the prompt is at the bottom of the screen here. It was Dream of a Distant Galaxy. What are your suggestions about what I should try to create here?
But maybe a friendly alien.
Oh, sure. Okay, so let's do a friendly alien. And do we want to have like high quality? Do you want that, or do you want it like in a style?
What do you
Friendly
think, Brooke?
alien.
I mean, if you do it like photorealistic, it might be interesting, but you could also just, with typically the stuff I do, I usually try to make it like pop art or like digital art, something that's going to be a little bit more,
So
not
did
as
you notice,
yeah.
we'll do both. Did you notice how it sort of was fuzzy and then got sharper? That's diffusion. So what you were looking at there was its first guess based at that high level representational, and then it went to the pixel level. So what you were looking at was diffusion there. Friendly? Okay. A little bit, okay, this is friendly. Maybe friendly. If I woke up and saw this above me, no. This one I would scream. Okay, so let's go and try, so we can try pop art. And notice it getting fuzzy, and then it will. Oh, fascinating, safety filter. I have no idea why. All right, give me something else to try. And notice that this is really blunt, right? This is like text, and then you're gonna get an image out of it. What else should I try?
Like along the same lines, or
Yeah, no, it could be something brand new. How about an illustration of something that you might want to have for a paper or for, we could try that. Dr. Yaba, what do you think?
Oh, goodness. We are doing an evaluation to see how well ChatGPT can do on maintenance of certification board examinations. So how about a doctor studying on a computer at home? This is potentially really disruptive because these are all self-paced exams, and you can feed multiple choice questions to it. We've done with test data set, and it does extremely well, like with the USMLE and stuff. So I don't know if that have any implications for these self-paced exams now.
Oh man, I'm looking, we're having a conversation shortly, aren't we?
Yes, we are.
I'm really looking forward to that. Okay, so let's try doctor studying on a computer at home.
I knew it. Male.
All male.
Caucasian, yep.
Mhm. So let's go and change this. And so here we see, and here we are having to say a female doctor. So that's why I'm wondering if reinforcement learning from human feedback could be, you know what? Let's, yes, this is the base of what you've been trained on, but let's make the first pass so I don't have to do this. Hands aren't too bad. What else should we do with this?
But these are only for medical doctors, so just
People
with just
true. And you notice the cues here are like, they all have stethoscopes on, which is interesting. Because heaven knows, that's you. First thing you do before you start working on computers, you go and you put on that stethoscope. Let's try another one. Is there any alterations we should try on this one? Or would you like to try something? Sanju, did you have something? Oh, Dr. Ya, go ahead.
Oh, style of Van Gogh, I think is
that's
always fun.
So something else I'll point out, which is funny. You notice that I'm sort of naturally typing a sentence here. So the folks who work and really get into prompts refer to these types of prompts as boomer prompts. because we can't help ourselves. We write sentences. Whereas you'll notice that Abby's prompts were like just words and concepts and the double parens around them too. And it's just like, so this is a boomer prompt. Does it work less well? It might in some cases. Not bad. And again, the hands here are getting a little bit freaky, but and I guess Van Gogh just didn't draw that many stethoscopes. We had to give those up.
Or laptops.
Or like, I love that the laptop, right, exactly. So Sanju, what would you like to try?
Actually, I was wondering if how this works with some numbers. So
Sure.
for example, say that, for my paper, I want to present really complicated descriptions. For example, like what will be interaction between X and Y on G. But my first challenge here, I know this is only for images, but I was wondering how this works with a whole bunch of values with images.
It has. If you could put something in the chat for me to try, I'll try that. It has problems with words and it has problems with numbers. I believe it will have problems with numbers because remember it's working in the latent space. So, and it's not that large of a model, and so it doesn't have a lot to borrow on where it's learned the words on a page. But it might be able to do some. But this is where ControlNet comes in, right? So you can absolutely imagine, training your own special ControlNet, which is able to take text and put it into an image in a particular way. Like here's the text has got to be there, but it might be on a page which is at an orientation, or at an angle. So you can imagine it might be able to do that. So can you think of, if you want to put something in the chat, I will copy and paste it from the chat and then I'll put it in here.
Let me see. Okay, I'm doing.
And interesting thing about this one's a bit larger, this model, but absolutely could run on a beefy GPU. This would not run as well on like a free collab, but maybe a paid collab this one could run on. So again, order of magnitude, and I don't mean in the incorrect sense. Usually when people say order of magnitude, they mean 10. I mean order of magnitude in terms of 100 times smaller than the Dall-E models, and also in terms of speed as well. So we're moving into something that's much faster to generate. The linear, okay, whoa, okay, let's see what it does. I have no idea what it's going to do.
Oh, there's one.
So do any of these make, I notice that it's making up the words here, right? And it's like, it's word-like, but it's not actual words. I love the sort of illustrations. It's like getting in the neighbor. This is fascinating.
So when I looked at, one picture can have different kind of variations. So say that in, say, a set package, we have one kind of picture. So we want to have some kind of variation for that picture. So I was wondering if there's some kind of applicability here. So when we provide an image, possibly from one step package, whether they can produce multiple different kind of versions we can use.
So yeah, so here it is possible to put an image in here as well. So if anybody has an image, I think that we can share that on here, but I'm not sure. So it can also do that prompt and image to image. but we just had to have an image to start with. Notice that I was doing stable diffusion 1.5. It actually goes up to 2. 2 has some problems compared to 1.5, actually more restrictions. But these are things you can try out. So you follow that link. Has anyone followed that link and tried some things already that you'd like to share? And Sanju, that's interesting what you're mentioning there. And I'm thinking, and this is something that we've not even begun to explore yet, because this model is brand new, and the training of this is not bad. I'm going to be really interested in seeing, they did training of all these different types of models. I'm wondering what training of this looks like. And I've not had a chance to look in here to see, yeah, they do. So they talk about training it here. So some of the things you're talking about you might be able to train them, right? So, train on a large number of illustrations. And especially if you have wording that takes you from one to the other or modifies it in some way, could probably be trained. What should I try next here? And I'm going to see if this has come up yet. Oh, please come up. Ah, this is killing me. Give me a quick sec. I'm going to see if I can. I'm going to restart this space. And see if I can get it to restart and get started, because I would love to be able to show you. It was so fun doing the real-time generation. I did a bunny. I did a terrible job drawing the bunny, but it filled it in beautifully. With sort of the pose and the direction, the gaze direction.
I tried in that one the original prompt that I used, diverse women coding, sitting at computers coding. Very different than what you get in Midjourney.
Really? Okay. Oh, here we go. Okay, great. Can you all see my interactive scribble screen? All right, I will try to draw something. So one thing to keep in mind with this, you'll need to reduce that size. It starts really big. So I can try a dog. Okay, so here's my picture of a dog. This is the tail. Come on now. That is the, uh-oh. Ears, snout. Legs. And you can sort of get the sense here that maybe data scientist was a very good profession for me, since I can't draw. Well, let's see what it does with that. So let's go and do the, now we can do a cute dog. And then what we're going to do is we're going to go ahead and run it. You notice that it's processing up here. A little bit terrifying, but my drawing was pretty terrible.
That's actually pretty good.
So
an interesting comment that you made. Well, you joked about, being a data scientist and not an artist. And I think an interesting conversation I've had with my friend of mine, a colleague of mine who does.
And you can't be both. I'm not. But I'm sorry. Yes, but go ahead.
Is just the concept of these tools potentially like democratizing talent. Whereas it used to be something unique and special about this person. And she is not, lamenting it, but she was like, oh, yeah, now this is something everyone can do. I just think that's interesting.
I think you're absolutely right. And these are really deep issues, right? I mean, this is, so the one is, yes, it can augment. So first of all, there's the issue of it being trained on artists' work without their permission and without compensation. So that's a thing. But then there's also, that question of, to be able to do this used to require a huge different set of skills that now everyone has. So can it augment your creativity, right? Can you do things very different than you could before? I know somebody who has been trying to train models on his artwork. He's an architect, actually. He doesn't have time to, but he's been training the models on his artwork to generate new kinds of things, but with different feelings, different. And so that is absolutely something that you can do. And especially with ControlNet that you were just seeing, you can actually get very fine-grained control of not just shapes, but conceptually as well, semantic segmentation, and it really opens the door to other kinds of things as well. So you have the blue period. Well, what if you have the slightly manic period? I mean, quite literally, you can say, okay, now here's the feeling that I want imbued in everything that I have, and then generate based on that. So whole new fields that are going to be opening up. But then, then you also have to, I mean, there's sort of an existential question that comes around this too. Who is creating? If this can create things better than I can, then we have the way we've done it in the past, then what is my worth? These are deep questions that we will be dealing with. In addition to making the cute puppies, we're gonna be wrestling with this as we move forward. All right. Any requests on things I should try drawing and see how well it can generate? So in the ControlNet that you have here, you might have to wait for many, many minutes before you can generate. But do know that if you want to pay, this is Hugging Face. If you want to pay them for compute, then you can clone this and then run this on your own. So I'll definitely be doing that. I've done that here. I'll probably take it down to a less expensive GPU. I put a pretty beefy one on it, so it'd be quick for you all. But know that that's possible to do as well, and it's not that expensive. Eventually, of course, this will absolutely make its way into applications, but it's about a week old. So this is going to be the way for you to get access to it right now. All right, folks, we're at the end of the time. Thank you very much for all of your questions, your comments, and suggestions here. Know that I'd like to point out a couple of things real quickly at the end here. If you're interested in diving a little bit deeper into any of this, we're having a workshop on March 27th. I'm sorry, we're having a symposium, March 27th, March 28th. March 27th is going to be workshops. The 28th is going to be all day AI revolutions in academia and in research. Speakers and panels on the impact. And this is still coming together. We were asked to do this very recently. So do not be surprised if you actually get asked to be on a panel, because we're going to be interested on many viewpoints of and many different uses. Second, we have our AI Summer. This is going to be May 8th to June 2nd, where we're going to be talking about prompting, prompt engineering, and all these different types of models, and how to train them and how to use them even from scratch. So this will be an intensive 4 weeks, but it'll be a great 4 weeks for you to get good background. We offer this every summer and every winter, and not a one of them has been the same, because the things keep on changing so quickly. So if you've attended this before, you probably want to attend again. Finally, I'll also mention that I do offer a semester-long class on the standard university undergraduate calendar on AI models, transformer models. So if you would like to sit in, or if you have students that you would like to attend, it's through the Data Science Institute, but they are more than welcome to participate in that class, where we get very much into the theory and the mathematics of what make these models tick. All right, I think that is it. Thank you all so much. Real pleasure talking with you all today.
Thank you so much. You guys are the coolest people I know. This is amazing.
See you all soon.